In this video, we are going to be looking at how you would calculate the average rate of a reaction. The average rate of a reaction is defined as the measured change, for example, the mass lost or the volume produced during an experiment, divided by the time taken for this change to occur. We can write this as the average rate equals the change in quantity divided by a change in time. In the shorthand, we can write this as the average rate equals delta Q, where delta stands for change in, over delta T for change in time. There are two ways that average rate calculations tend to be given. The first way is when you have a table of information, and the second way is when you're given a graph. For the first three questions, we are going to use this table of information to complete our calculations. So question A, calculate the average rate for the first 4 seconds. So the first thing to do is to write in your formula. Delta Q over delta T. Our change in time is the first 4 seconds. So 4 seconds minus 0 seconds. And then we look at our table and we find out what volume of gas was produced at 4 seconds. So it was 92. And what volume of gas was produced at 0 seconds, which was 0. So then we have 92 divided by 4, and that gives us an answer of 23 centimetres cubed per second. Okay, remember to use your units correctly for these questions. B, calculate the average rate between 2 and 6 seconds. Again, our first step is to write in our formula. Our change in time is between 6 and 2 seconds. At 6 seconds we have 114, and at 2 seconds we have 47. So 67 divided by 4, and that gives us an answer of 16.75 or 16.8 centimetres cubed per second. And finally, calculate the average rate between 4 and 8 seconds. So doing the exact same thing again, writing in our formula, our change in quantity over our change in time. So in this case it's our change in volume of gas over our change in time. So between 8 and 4 seconds. At 8 seconds we have 118 centimetres cubed of gas produced. And at 4 seconds we have 92. 118 minus 92 will give you 26. Divide that by 4 and we get 6.5 centimetres cubed per second. Let's have a look at the second way these questions can be shown. So the other way that rate questions can be shown is by giving you a graph. So here we're to use the graph to complete this question. So calculate the average rate between 5 and 15 seconds. Again, first step is the exact same thing. We're going to write out our formula. Change in quantity over change in time. Between 5 and 15 seconds, our change in time is 15 minus 5 here. Now for these questions, I would advise you to keep a ruler handy, because it makes it much easier when reading figures off of the graph. So at 15 seconds we go up, use a ruler to point to where our line meets, and then if you draw that across, and then read your figure off the side, you will see that that is 37 litres. And then you do the exact same for your value at 5. And that value is 24. So then it's 37 minus 24 is 13. 15 minus 5 is 10. So your answer is 1.3. Now be very careful in this style of question because your units are different. So here we have litres produced and the time is in microseconds. Okay, so either you have to write out litres per microsecond or you can put in the symbols if you know them. We've got litres, microseconds, the symbol is a bit like that. So that means litres per microsecond there. And again, B, we'll just do the exact same thing we did before. The change in litres produced over our change in time. Our time is between 20 and 10 seconds. Again, we use our ruler to go up to our graph. Go to the 20-second mark and extrapolate up until we meet our line, and then we just take that line across. And that value here is 41, and we do the same at 10. And here we have 32. Oh, there we go. You can see that now. So we have 41 minus 32, which is 9. 20 minus 10, which is 10. So here we have 0.9 litres per microsecond.